Eggs and Issues, a monthly business program presented by the Portland Community Chamber of Commerce. Eggs and Issues is supported by presenting sponsors Bank of America and Martins Point Healthcare, in cooperation with Harvard Pilgrim Healthcare, First Light Fiber, and WEX. Reception sponsors KeyBank, Clark Insurance, and Veraldana. Tomorrow's Leaders and Entrepreneurs sponsors AAA Northern New England and Springborn Staffing Center. Community Corner sponsor Baker Newman Noise. Parking is provided by CV and Mahar Engineers. Our exclusive radio sponsor, WGAN. Listen weekday mornings to Ken and Matt on the WGAN Morning News. Print sponsor, The Forecaster. TV sponsor, WMTW. And e-media sponsor, Maine Biz. Special community partners, Anthem Blue Cross Blue Shield, Spectrum Healthcare Partners, the University of Southern Maine, and Southern Maine Community College. And now, please welcome Portland Community Chamber of Commerce President, Jack Lufkin.
Good morning, everybody. Good morning. Thank you all for coming out to hear Dr. Liu, his presentation coming up very, very shortly. Rainy, icy January morning. That's always what we get with Eggs and Issues this time of year. So really appreciation to all of those who are in the audience. So as was mentioned, my name is Jack Lufkin. I'm a commercial lender with NBT Bank here in Portland, and I'm the volunteer president of the Portland Community Chamber of Commerce. And I just want to pause for a moment and talk about some of the advocacy efforts that are ongoing. I do want to get right to the program, so I'll be brief. Last night, the Portland Health and Human Services Committee held a public hearing relative to the mandatory paid sick leave. If you have not yet looked into this, if you have employees anywhere in Portland, I implore you to please read the bill. This will have impacts, and I'll leave it up to you to judge. We have taken a position against this particular one, particularly with the efforts that are happening in Augusta, leadership change, the referendum possibility. We think it's time for the city of Portland to pause on their own specific efforts. But I won't belabor that point. I want to get right to the program. So we're trying to keep this short and get more time for the speakers, so I'll just point your attention to the card that's on your table, which talks about the upcoming chamber events. We do later this month have the annual event. So it's going to be our annual event award presentation, Imagine Portland. It is the biggest networking event of the year, and this year we're again celebrating the individuals and organizations that have promoted growth and prosperity in the Portland region. You will be receiving an email today after Eggs and Issues with instructions on how to register for the event. We are on track to have more than 900 people at the event, making it our largest event to date. Be sure that you register early because you do not want to miss out. One other event I'd like to mention, because it's tonight right here in Portland. We normally in Portland don't have business after 5 events, but we're doing the event in conjunction with the Falmouth Cumberland Community Chamber of Commerce, and that's going to be at Boone's Oyster House. This is going to be a fun networking event and a chance to meet some new chamber members. And speaking of new chamber members, I want to recognize some of those that have joined or rejoined over the past month, and those are People Ready, Lowe's, One Net Maine, Kushnock Resiliency Advisors, Cape Cottage Family Dental, Live and Work in Maine, Hub International Cumberland Foreside, Terracon Consultants Incorporated. We want to welcome you to the chamber, and we look forward to working with you. Can we get a round of applause for our new members? AAA of Northern New England and Springborn Staffing provides support for our Tomorrow's Leaders and Entrepreneurs program, which allows area high schools and college students to attend Eggs and Issues. Because of the cancellations, we have a few less people than we would normally have, but I believe we still have students from Cape Elizabeth High School, and I think we have some from the University of Southern Maine. If you're here, please stand and let us congratulate you. It was icy this morning. The Portland Public Library is our FMI sponsor, and they will provide additional information regarding today's topic after this event, and you will receive that in your email inbox later this week. Baker Newman and Noise sponsors our Community Corner program. Today's Community Corner is the American Cancer Society. The American Cancer Society is a global force of 1.5 million volunteers dedicated to saving lives, celebrating lives, and leading the fight for a world without cancer. From breakthrough research to free lodging near treatment, a 24/7, 365 live helpline, free rides to treatment, and convening powerful activists to create awareness and impact, the Society is the only organization attacking cancer from every angle. Increasing colorectal cancer screening rates through the 80% by 2018 campaign and the Mission HPV Cancer-Free Vaccination Campaign are just two examples of programs that are helping to reduce the cancer burden in Maine. The American Cancer Society has 7 Relay for Life events, 3 Making Strides Against Breast Cancer walks across Maine, raising funds to save lives from cancer. For more information or to get involved, go to www.cancer.org. And I'm pleased to say that we have with us from the Cancer Society today, we have Ellen Russell, Revan Oliver, Jennifer Ruggiero, Brian Casanova, and Nicole Hensler. Would you please stand and let us thank you for your work? Now, as promised, on to today's presentation. Dr. Edison Liu is the CEO, president, and professor at the Jackson Laboratories. The Jackson Laboratory is a nonprofit scientific research institute founded in 1929 in Bar Harbor to study the then new field of mammalian genetics. The Jackson Laboratory has become a major international research center for complex genetics and genomics. It is the only NCI-designated cancer center in Maine and the state's 17th largest employer. Jackson Laboratory generates nearly $760 million a year in calculated economic activity and maintains a physical footprint across 3 states and in 2 international locations. Dr. Liu will discuss the past, present, and future plans of the Jackson Laboratory. Before coming to the Jackson Laboratory, Dr. Liu was the founding executive director of the Genome Institute of Singapore and was the president of the Human Genome Organization from 2007 to 2013. Without further ado, I welcome to the stage Dr. Edison Liu.
Well, thank you so very much, Jack, and thank you very much for braving the weather to come and hear about my favorite topic, which is the Jackson Laboratory, in one of my most favorite cities, which is Portland. You're very fortunate to live in this town that is really not only beautiful, but it have fantastic restaurants, which makes for the stop between Bar Harbor and Connecticut, which I'll show you, we have another campus, a really absolute delight. The Jackson Laboratory started in 1929 by these intrepid individuals. The founder, C.C. Little, was the president of the University of Michigan, but really his heart was in science, the science of genetics, which in the turn of the century did not exist as a term. I mean, think about how genetics is front and center now, and it wasn't even known as a field. But you fast forward that, and this is the Jackson Labs today. 4 campuses, because we count Ellsworth, this beautiful facility in Ellsworth, as a campus. Our roots are in Maine, and it will remain in Maine. We've started a new campus in Farmington, Connecticut for Jack's Genomic Medicine, and a production facility in California. And just recently, we've had entries into China in Xi'an, which is in the west, and in Shanghai, as well as in Seoul, Korea. So our footprint in Bar Harbor, a town of 6,500, is global. The mission of this not-for-profit is bipartite. One is what we do as scientists, that is to discover precise genomic solutions for the disease, and the other is what we do for the rest of the research community, that is empower them to improve human health. And we do so in this manner. In our research areas, as you heard already, we are the only NCI-designated cancer center in Maine. I myself is a cancer center director because I'm an oncologist by training. We are NIH centers for Alzheimer's disease, addiction, aging, genetic diseases, and various other centers that are really very basically focused. But you see here the aging, cancer, microbiome, dementias, addiction, rare diseases, and very importantly, as you'll hear, computational biology. How we compute biology nowadays is a key forefront for what we do. JAX accounts for 70% of all NIH grants coming to the state of Maine. The other part, which is to empower the biomedical community, is really fostered by the JAX Mice and Clinical Research Services, where we provide research mice and services to the rest of the world. Every year, we distribute over 3 million mice to 2,000 organizations in 72 countries across the world. As I said, we're small, but we're really global. This is born into our statistics in that we have, in total, 2,300 individuals. We plan to increase to about 2,500 individuals with 71 faculties across the 3 campuses. The major campus here is about 1,600 individuals, and we're the second largest provider of research mice in all of North America, and the only not-for-profit in this space. We garner last year $91 million in research grants, the vast majority from the National Institutes of Health, and our academic endowment is actually about $270 million. Our gross assets have now exceeded $1 billion. It's doubled since I arrived, and the annual budget is about $400 million a year. But I think this is not, I want to show you that this is not a stable function, as impressive as I think it might be. But this is due to a lot of hard work that is shown by this one graph, showing our revenue growth over the last only 6 years. But you extrapolate it over 10 years, we had more than doubled our revenue, but not by outward investment in, it's really by organic growth and putting out a great quality of work, both in research and getting these NIH grants, but also in the products that we actually sell. Our annual growth rate is about 9% per year. It's pretty darn good. One of our board members said, if you weren't a not-for-profit, I want to buy you. As you heard, our total economic impact is now actually near $1 billion in 2018, projected for 2019. 17th largest employer in Maine, 5th largest not-for-profit in Maine. The only groups that beat us is Bowdoin with a, I don't know, $10 billion endowment. Colby and the 2 major hospitals, Maine Medical and Northern Light. So I think, to be honest with you, they are really illustrious partners to be in that stratosphere. Our wages grew 56% faster than the Maine average, and we really are not just in Bar Harbor or in Hancock County. We have employees living in 12 out of the 16 Maine counties. Very importantly, we not only invest in you all as our partners in economic development, but we invest in our people who not only stay with us, but they circulate through the Maine economy. Since 2000, the year 2000, we have supported through our education system for both bachelor's, master's, MBAs, and even PhDs, 1,000 of our employees to enhance their capabilities. We engage 600 Maine vendors, and I'll give you 2 examples. Clear H2O produces these hydrogels that if you're a long-distance runner, sometimes they would actually pick up this gel instead of water. It has nutrients as well as hydration capabilities. It turns out when we ship those 3 million mice all across the world, we put a hydrogel in there because it's the safest way. We're the only group that when mice get shipped, they gain weight in transit. Honest, this is honest to God true. And because of our consistent business with Clear H2O, they were able to expand their business on a national basis. And we have the largest wood pellet plant in, I believe, all of the Northeast, and we spend about $2 million a year in wood products from Maine to generate energy rather than relying on foreign oil. Now, what I want to transition to at this point is to tell you what we do beyond economic development, which I believe is extraordinarily important. And that's, quite frankly, one of the reasons why I took this job, that it wasn't just about science. It's about people. It's about community. And this is about how, I'm going to talk about how our science has an impact on the world and your health. And I'm going to rather talk about what we did before, is what we are doing now and what we're going to do in the future. In order to do that, I want you to imagine a future, okay, where I can predict when you will get any disorder, when I can treat that disorder in your unique way, okay, because not everybody should be treated in the same way, and because I know when you're going to get a disease to prevent that disease from ever happening. Can we do that? Well, we're not quite there. All right, but we're moving towards that, and I'll show you how we're going to do that. And one of the ways is, if you talk about the endpoint, is to create a precise medical roadmap for a disease-free life. All right, and now, one of the reasons why we haven't been able to accomplish this, because everybody is trying to do this, is because of you. You're really complex. Not one person is so different from the person next to you that to think that we can treat everybody the same, or that everybody will have the same disease, and even if they have the same disease, that the outcomes are exactly the same, is, as you well know, is completely wrong. Okay. So how do we go about doing this, and why are we so complex? It's really all in your DNA. Every cell in your body has the same DNA. But how it's expressed, how it's manifested, is the stuff of the biology that we study. But in every cell in you, there's about 20,000 genes operative at any time. Okay, that is encoded in about 6 billion nucleotides. 6 billion pieces of information. This is actually double because you have one from your father, one from your mother. Okay, but you have 6 billion pieces of genetic information. That's 90 gigabytes of information. That's as much as your iTunes library of 18,000 songs. Now, if you consider that there's 8 billion people in this world by 2025, and that maybe a quarter of the 8 billion will be sequenced, 2 billion people with this 90 gigabytes gives you 40 exabytes of information. Now, let me put this in perspective. If you take YouTube, Twitter, and all of astrophysics, we exceed in our genetic information as a population than any of this information that we have now. Okay, that's humongous, right? Okay. But we now have the tools, both biologically and computationally, to actually tackle this problem, which we never have been able to do before. One of the issues for us, for me to be able to project, to make this roadmap of your medical life, is that I need to know all the mutations in your DNA. And in fact, every one of you will probably have about 250 to 400 mutations in you that are considered perhaps deleterious, but you don't have any disease. And that's the complexity of genetics. Some people have these mutations and they never get disease, and other people's do. And that's why we are in this game, because we want to deconvolute that complexity. Then we have to say how you are diverse from everybody else. You're different from the person next to you for up to 4 million base pairs. Then we need to compute all the environmental exposures you have, because environment is indeed important. If you have a heart disease gene and you eat a completely vegan diet with a caloric restriction, you can delay your heart disease by a decade or two, okay? So the genetics is not totally deterministic. It is involved in environment. And we need to compute also all the responses in every organ in your body, and we have to do it in the arc of time and an aging process. Now, if we had all that information, then I think, theoretically, I can compute your future, all right? Not perfectly, but we can do an approximation just as much as nowadays. By the way, this is what people do for weather prediction. When I was growing up, we used to joke that weather prediction was terrible. But, you know, quite frankly, we have TV stations that tell you when a tornado is coming weeks in advance, okay? Now, why is this never going to happen if we study only human beings? That's because I know I can sequence you and know all the mutations, but I'm not going to be able to know the full diversity of humanity, and I certainly won't be able to detect all the exposures that you've had all throughout your life, and I'm definitely not going to biopsy your brain and your heart on a routine basis to get at how it affects those organs. And chances are I won't be able to know you over the arc of time in your lifetime to know how those changes are manifest. So even on a theoretical basis, we will never achieve that predictive capability studying only humans alone. At the Jackson Labs, we have an entire center devoted to human genetics. We have to have that because that's the most important. But we have a secret sauce. And our sauce is going to give us precise and predictive digital models of human disease. Maybe not of a human being, but of the diseases that affect humans. And this is the critter that's going to help us. Okay, this is the lab mouse. Now, why is this important? It is at the Jackson Laboratory, the 2,200 individuals that we have are all devoted to complex genetics and functional genomics using only two organisms of study, the mouse and the human. The mouse is about 95% identical to the human in genetics, and we diverged about 60 million years ago, but the organs are pretty much the same. We're not the same, all right? Let's be very clear about this, but we're similar enough so that when we study the biology and the genetics of the mouse, we can make inferences in the human and vice versa. So what we're doing is actually taking all our profound knowledge of the mouse, porting it over to the human, taking human data, porting it back into the mouse, and this iterative cycle of saying, let's model the human disease in the mouse. Oh, we found something very unique that we have not seen in this human disease. Let's go back into the human disease and ask, does it exist? And this iterative cycle of refinement is actually getting us to the ground truths of human disease. Now, I'll give you one example that's very new, hot off the press. And just recently, we took 400 mice that are highly genetically diverse. This is our specialty. And we mapped where the genes are that actually induce diabetes. Now, 1 in 10 individuals in this audience probably have diabetes. It's defined differently than in the past. And about half of the human population will have a propensity for diabetes. So it's a worldwide problem. This is the type 2 or adult onset diabetes. But these genes are then mapped almost perfectly to the human genes that have been identified, okay, using what we call association studies. But think about what the difference was. First of all, it says that the mouse and human genetic to disease orientation for diabetes is really unbelievably conserved. We can learn from the mouse because it's a reflection of the human condition. However, it took 400 mice in one experiment for us to map what it took 15 years and 200,000 human beings in order to give you the information. That is a expansion of power by over 1,000 and reduction in time and cost by more than 1,000. This allows us to have tremendous power in mapping disease-related genes. But let's zoom in on this. Not only do we have this correlation between mouse and human, but we are even more precise, because you see here, this is actually each represents a chromosome, and the regions that are associated with an outcome, what we call a phenotype, like insulin level at 14 weeks, glucose at 10 weeks. We have this kind of precision in mouse experimentation that you will never get in human studies. No way you're going to get that. But it is this type of precision that is necessary for us to put into the computer and compute what a human being would be like. Now, so recall, there are absolute limitations in doing studies in human, but if you add the mouse, we can then fill the gaps of information in ways that are impossible in any other way. And that's what the Jackson Labs really is going to do. Now, you can get all this information. Remember, 40 exabytes, et cetera, you know, then it becomes an information problem. You know, no matter how smart you are, you're never going to be able to read 40 exabytes of data. So when we get this information, what we hope to do is actually discover the genetic causes of disease. We can model it in a mouse model, and we can test changes in diet, in drugs, and then get at a treatment for diseases such as type 2 diabetes. As I mentioned to you, this data really becomes a problem. So how you handle the data has become the exact reason why you have Google, Facebook, Microsoft, and et cetera. Well, I'll tell you how we're going to try to do this. And it has to do with data structure, okay? And this is now called a data cube concept. If you imagine that each cube represents a piece of information, and this is, let's just say, a nucleotide, A in U or a G in U, and you stack that up across your 3 billion base pairs, 6 billion if you double it, and that's called genotype. Then for each change, you say, well, how's your glucose different? Or do you get Alzheimer's? What is your cholesterol level? That's called phenotype. So you already have a two-dimensional map of your genes with your outcome, your physiologic outcome. Then you cut it across all environmental structures, and you cut across age in a multidimensional manner, and this is the data cube that represents you, specifically you as an individual. Now, the beauty of this data cube concept is, remember, if you think that the cube is you, then even if I don't have all the information, there's enough of these little dots that I can reconstruct a cube structure. You know, so progressively, I'll be able to approximate you over the time, the arc of time. So this concept has been used before and used now. This is Earth Systems Laboratory, and this is geologists and climate specialists who basically take the entire Earth, map it, just like I map your genome, and then for every nucleotide that I said we map your genome, they're mapping a geographical location and say air temperature, carbon dioxide, precipitation, in that little space that is there. And by doing this over the arc of time, they can actually make predictions of will the Sahara expand? You know, the Chinese are very worried about the Gobi Desert expanding. And this is this type of information that actually gives us the health of the Earth. That's one planet compared to the 8 billion people that we have. Now, how we're going to go about doing it at JAX is we have people to analyze human data, and we'll fill the human cube. Okay, it's not perfect, right? Then what we're going to do is actually complete the cube with mouse data. Once we have the general framework in the human to plug in the holes, we compute then all this complexity, the vectors of systems that actually work together, gene-gene interactions, gene-environment interactions, and then port that back into humans. That's how we go about doing it. We're doing it right now, but we're going to do it in a remarkable scale in the future. So back to this iterative cycle of mouse-human interactions, all interfaced by this computational genetics, and then we're able to complete the cube of humanity, the human medical condition. Our goal, as I mentioned to you before, is to give you a precise and predictive digital models of disease. All right. And we're not there to do the whole human being, but we're doing this for type 2 diabetes. We're beginning to do this for Alzheimer's disease. We're doing it for specific cancers as well. Then with this information, we're going to be able to define new tests. We can actually look at interventions, physical interventions that will prevent disease, actually have agents to prevent disease and agents to treat the disease. This information is beginning to be used by drug companies to actually find new drug targets for all the ailments that you have. But this is not just limited to type 2 diabetes, but as I mentioned to you in our little Venn diagram, in many different disorders, this kind of approach is really, truly applicable. Our goal, back to the very beginning, is to provide for you and for the medical community a precise medical roadmap for a disease-free life. We're not there yet, but just around the corner in Bar Harbor, come by and see how we make the sausage. So thank you very much. All right. I'm sure there are some questions.
Yes. Dr. Liu, thank you for the presentation. Again, I'm Jack Lufkin. I'm sorry I didn't say this when I got up there, but we have 2 microphones. Please come up and state your name and if you represent an organization, and feel free to ask a question. And since I'm here, I would like to perhaps ask the first one. One of the last exit issues we did was relative to workforce development. Obviously, you were doing some cutting-edge work, and thank you again for explaining a piece of that to us. We hear time and time again about the challenges of workforce development in this state, but you also have sort of a larger purview where you do have multiple locations throughout the United States, internationally. Can you tell us what JAX is doing relative to the workforce development? Are there lessons that we could learn in the state of Maine relative to attracting or growing our own through our university and college system? The researchers, the people that you need to conduct this cutting-edge research.
Right. I think that's, by the way, it's a very important question. When I was in Singapore, I ran a research institute that was fundamental science and genomics, but I reported to the Ministry of Trade and Industry. Okay, not Ministry of Health and so forth, because they view science and technology as an arm of industrial development, not necessarily only for health and education. That's my view. And there are several, perhaps, lessons that are unique to us, but perhaps has some generalities. First of all, we invest in our people. When we raised our minimum wage from $10 to $15, an hour, we changed in the 2,000 individuals at that time, we changed that rule. We actually increased the salaries of 850 individuals. So don't think that we're all a bunch of egghead PhDs. We have line workers who have a high school education only, and they're represented in those 800 individuals. But many of them, the most unbelievable piece was when I started talking to the the mid-level managers, and they said, well, I've been here 20 years. I mean, how old are you? Oh, I'm 38. You've been here since 18? They said, yes. And I got my bachelor's degree through your program. Or I got my MBA through your program. I mean, it's fantastic. And that's workforce development. That's, to me, workforce development. The second thing is the uniqueness factor. As I mentioned to some of you in the mixer outside, is Cape Canaveral was a nothing town until NASA came around and shot rockets into space. At that point, then they had the best engineers, the best test pilots congregating in this little town of Cape Canaveral. Well, at the Jackson Labs, we're the only place that you can be if you want to study complex mammalian genetics in the mouse. We're really the only place. So to be frank with you, we haven't had a lot of problems attracting the very specific individuals, because we're the only place. But the third part of it is there's a circulation of talent. We bring people from the outside in, but our CFO was the CFO for WEX. Katie, our executive vice president, was chief administrator for Bowdoin. There is a circulation of talent, and the issue here is there's got to be comparable jobs in different companies or in different organizations for these highly qualified individuals to circulate. Now, some of that is a cluster thing. If you have a cluster of universities, that's great. But think about it here. What's our cluster? Well, for me, very unusual. If you think about it, Maine has the most important veterinary clusters in the United States. Jackson Labs is unique. There's no other place like this in the world. IDEX is unique. Vet's Choice is unique. And there's a lot of peripherals that have to come around. And I believe that if there's one area is veterinary services and veterinary sciences that can be really here. So, okay, I guess somebody actually works in the field as well. But you know, let's be honest. I mean, we need good universities, but it's necessary but not sufficient, right? You got to have them, but by themselves, it's not going to work. So, yes, sir.
Good morning. Tim Mahalik with Skowhegan Savings, but I'm also a volunteer with the Juvenile Diabetes Research Foundation. And we've seen these examples where type 1 diabetes has been cured in the non-obese diabetic mouse model multiple times, but we haven't had much success in translating that into human cures. And I wonder if you could comment on the obstacle and if you're doing much type 1 research.
Actually, we're doing a lot of type 1 research. Dave Seres is actually one of the key investigators, by the way, who discovered that type 1 diabetes is not a primary islet cell problem. It's actually an immunologic problem, very different from type 2 diabetes, okay? These are nuances of biology, but they were extraordinarily important nuances, and they came out at the NOD, all right? And actually defined the immunologic subsets that are involved in that. Now, let me just say how complex it is. Do you know that immunology has everything to do with cancer? We've known this for probably 50 years, right? But those 50 years of experimentation and research did nothing for us until the last 5 years. And that's because we understood the complexity of the immune system and be able to engineer it. Just as I mentioned, we're learning the complexity of genetics and engineering the genes. And now you have curative treatments for cancers that were previously incurable. Jimmy Carter is a classic example. He was in his deathbed with melanoma. Now I just heard he was in China giving a talk after receiving immunotherapy. We just made an observation and it has to do with actually intervening in the immune system in the mouse model that actually prevented the onset of type 1 diabetes. The problem is, sir, once you have type 1 diabetes, no matter what you do, other than transplantation of islet cells, you'll never give it back. So that is part of the problem. Whereas type 2 diabetes, you have a time, you have 20 years before you became overtly diabetic. The type 1 diabetics, overnight, they become diabetic. And once they're diabetic, you can't turn the clock back, as you well know. But we're hoping that we're able to, using genetics, identify people at risk, monitor them more carefully, and just as when they begin to start, you intervene with an immunologic intervention. And that's really the goal. Yes, ma'am.
Good morning. Thank you so much for a wonderful presentation that was simple, because sometimes what you do seems a little complex to those of us on the outside. My name is Sarah Toomey. I work for Marsh, and I'm really curious about the environmental piece of what you're doing. Your example was about diet, and I'm curious, does environmental also go into things like where you live in the country? Like I have a neighbor who has lung cancer, and supposedly in Maine, there's a higher propensity for people to have lung cancer. Think of Flint, Michigan, where children and families have ingested lead in the water. Think of skincare products that we use on our skin that might be ingesting chemicals. Is that a component of your environmental right now, or something that you're thinking about including the future? And
No,
how would you pull that
well, let me
in?
just tell you, just the dietary issue is one thing we're absolutely focused on. And I'll just give you two experiments. Dietary restriction by changing the components of the diet actually block the onset of Alzheimer's symptoms. It doesn't totally eliminate them, but using the mouse as a model, instead of waiting 70 years in a human life, we can look at 2.5 years of a mouse life and actually see conclusively that exercise and diet really will reduce the onset of the cognitive decline in Alzheimer's. But more important than anything else, because people have suspected that in human epidemiological studies, we now know the mechanism behind it. And interestingly, the mechanism is inflammation. It's the immune system. The second is longevity. We just completed a study with Calico, which is a Google-funded company in San Francisco, on the genetics of aging. And we found that caloric restriction, as has been seen before, prolongs a healthy life. But we also know that 1 day a week fasting is as good as a 20% reduction in caloric restriction. So now we can map the genes that are interacting with that environment. You couldn't do that in other ways. Yes, sir.
John Spritz with Burgess Advertising and Marketing. On your Venn diagram, you indicated that Alzheimer's and dementia were two of the areas that you were focusing on, and we are in a state with the oldest population in the country, and we're getting older. Is there any way in which the research you're doing at JAX interacts with or communicates with our resident population of older people?
Oh, absolutely. And Luann Ballesteros, if you can raise your... Luann here is actually one of our key organizers for this interaction between our scientists and the clinicians and the Alzheimer's Society. We work closely with Senator Susan Collins, who's fantastic in pushing forward for more funding in Alzheimer's research. The answer is absolutely yes. And the reason for that is severalfold. Number one, the time from a basic discovery to impact on human beings is extraordinarily short now, unlike the times before, including the genetic diagnostics and what have you. For example, the observation that certain exercise and dietary interventions can prolong the healthy life of people who are even susceptible can be easily applied in the populations now. The second thing is that what we found is that we have unique organizational capabilities, being a singular structure that uses teleconferencing. And we did this with the cancer groups, the Maine Genome Cancer Initiative with the Alphon, of using JAX as a convener and then using our clinician colleagues as partners in disseminating technologies across the state for cancer. We hope to do the same in Alzheimer's as well, and so stay tuned. We're very excited about this. Yes, ma'am.
Good morning, Susan Morris with New Hike Group. I'm the one that spontaneously burst into applause regarding the focus on vet science. Just to mention the idea, it has long been my thought that Maine could be the global leader in not just vet, but also pet lifestyle. And I don't work for LL Bean either, but I believe that we could attract and keep many, many people if we were to be the leader in the world on pets and vets, both from a science and a lifestyle perspective. So that's just my little comment on why I went, yes, let's do this. But apart from that, the question I have for you is, I kind of was thinking of Google X when you were talking about what you do with the idea of this secret lab of everything that's going on. And I wonder if you could talk to us a little bit. You are a nonprofit, and how open are you with the global world of science on what it is you're doing, and who do you, I know you are unique, but who do you see as your competition, and who do you see as your strategic partners, and whether those are global corporations or universities or whatever? Could you talk to us a little bit about the environment in which you're operating?
So let's be very clear. As a not-for-profit, we have to share our data. I mean, that is part of the regs, IRS regs. But beyond that, the reason why we stayed a not-for-profit is because we have this mission of conquering human disease. One thing about academia that you should know, and by the way, it's not dissimilar to this cluster concept of companies. We're both competitors and collaborators. That's just the nature of the beast. And it just so happens that at JAX, we have a lot more collaborators than we have competitors. For one reason is there's not a whole lot of people standing around who can compete against us. So instead of being a walled, citadel, we decided to open our gates. And you may know that we're, quite frankly, one of the most respected academic centers simply because we share. We share virtually everything that we do. Of course, you have to have protections. Of course, we patent. Patenting does not mean we don't share. It just protects our own interests in the long run, right? And that's really the key. I just want to get back to your cluster concept. The gentleman that asked about the aging population, I've actually suggested to Governor LePage that one of the key initiatives that we could embark on is to turn our negative, which is the demographically oldest state in the union, into a positive, because everybody's growing old. Can we actually use this as an experimental station to actually learn the quality of aging? And by the way, the extreme temperatures only are to our advantage, because if we can beat growing old in the cold, they can sure beat that in California, okay? So that's why we're investing in aging studies in a big-time way. That's why we're investing in Alzheimer's. And this is why, let's forget about moaning how bad we are. Let's figure out how we as a community, the beautiful thing about Maine that I've learned is that everybody's part of the Maine community, even those of us who just arrived, and let's take advantage of that. Sir?
Yeah, Doctor, as a significant stakeholder in Maine and as an organization that is pretty good at looking into the future and then moving in that direction, what advice do you have? We've got a new administration. Many people view it as a new age possible here in Maine. What advice do you have for either the new administration or for those of us that are active in civic affairs in Maine in terms of moving forward?
Well, each individual topic has its own, flavor and nuances. I guess my only more general statement is I hope we don't have to whiplash from left to right, right to left all the time. And there's got to be a middle ground somewhere, I don't like taxes any more than anybody else. On the other hand, we got to have essential services. How do we do it without demonizing everybody? I believe, personally, is one of the most important things. My eldest son, who's quite a thinker, when I asked him, what do you think? Periodically I ask the young folks, what really bothers you the most? And he said to me, the post-truth world. And I said, God, it must be genetics. You're brilliant. Because if you can't agree on truth, where are we, And so it's that whiplash, and let's agree on a body of truth so that we can really have a civil discussion. That's the only thing I hope for. Yes, sir.
We have time for one more question.
Yeah.
Yes, good morning. Jim Irwin from Pierce Atwood and chair of the board of the University of Maine system. And I have a question about an issue that I know is becoming greater and greater in the world of genetics, and that is the question of how you manage the emerging ethical issues that are arising, the more knowledge, more power, all of that. I just wonder if you could talk for a minute about how you are managing ethics both today and for the future of what you do.
Yeah, well, first of all, we take this ethics issue extraordinarily important. If nothing else, we have under our charge at any one time, 1.5 million mice, okay? To us, they're living creatures. We take our role as stewards of a natural resource very, very seriously, okay? So that's number one. The second thing is the genetics, and I think some of you may have heard of CRISPR, which is perhaps you had molecular biology to be able to clone the gene. You had then polymerase chain reaction, so you can read any genome. And now you have CRISPR, that you can change any genome. And that is extraordinarily powerful. The greatest fear, of course, is changing human genomes for generations to come. Let me say that it's going to happen only because the technologies are so powerful. If you had a life-threatening disease in your family and it was offered to you to eliminate that for the rest of your lineage, I think there are very few people who would say no to it. The problem is we're not there yet. Okay? Until we're there, meaning I know I can get at that mutation and nothing else, we've got to. This is not the same as testing antibiotics, because the consequences of making an error goes way down into generations. And so that's why those of us who work in the field have a moratorium right now in what we call reproductive genetic engineering in humans. But we don't want to stop science. And already we can cure human diseases by changing the genes of the cells that are not being passed on to your kids. All right. There are ways to change the gene in eye to prevent blindness. We were party to a genetic drug for several pediatric neurologic disorders that were passed by the FDA. It's remarkable. These kids were going to die a terrible Lou Gehrig's type death, and they're not cured, but they actually can live a relatively normal life at this time. It's a fantastic story, okay? We're going to continue to work on this, but the key issue is really how do we manage, which, by the way, is not a scientific question. It is really a population question. It is a citizens question. Manage changing the genomes of that will be passed on in a generation. Now, to be frank with you, I don't think you've heard this terrible story about this one Chinese doctor who changed the genes. Everybody, including the Chinese government, thinks this is awful, and he's being investigated right now. Renegade systems like that, it's not going to make it, even though it makes headlines, it's really not going to. It's not going to change humanity. It just takes too long to change humanity. But there is, and by the way, the Homeland Security and the CIA are actually quite concerned about what we call gene drive. I don't want to go into the details of it, but it's actually taking a fly or organism, changing its genes so that they will pass on a lethal gene, a lethal to the fly. Okay. You might say that's great, but if you can imagine passing on a lethal gene to bees, and you literally have a bee collapse in any country means a collapse of agriculture. In fact, the Army, the DARPA, is funding one of my good friends who is a fantastic bee researcher. The Army is funding research in bees because they are concerned about the current series of bee hive collapses as well. Can you imagine that this is, you would never eating eggs this morning think that bees are going to be that important to the military, but it is really important. And it's all about genetics. So we need to be good at the technologies, but we need to manage them in an intelligent way. And that's not the domain of scientists. It's really your responsibility. And in a democracy, it is you that's going to decide what we as scientists will do with these technologies. So thank you so very much. I appreciate it.
Thank you, Dr. Liu. That was a fascinating presentation. Just want to let you know that we're going to be, on behalf of the Portland Community Chamber, making a donation in your honor to the American Cancer Society. In closing, you can stay up to date by connecting via Facebook, LinkedIn, YouTube, and Twitter. And don't miss next month's Eggs and Issues, where our speaker will be Rich Gotham, the president of the Boston Celtics. With that, have a great rest of your day and week.